Most students find the remainder and factor theorems confusing because they try to memorize the steps instead of understanding the logic. But what if I told you these are just shortcuts for long division? Hi everyone, I'm Wangyal. Today we are going from the absolute basics of polynomials to mastering every type of problem you'll face in your exams. Whether you're in ICSE class 10 or CBSE and West Bengal board grade 9, the logic is universal. In this video, we'll break down the why behind the math, solve complex problems together, and ensure you never get stuck on these theorems again. Let's dive in. To begin with, let's start with polynomials. The simple definition of a polynomial is that it is an algebraic expression made up of variables, constants, and coefficients connected by a plus or a minus sign. And the important thing about a polynomial is that the degree of the variable means the power or the exponent of the variable is a whole number. Generally, it is written as the power is a non-negative integer, which is also known as whole number. So let me repeat, a polynomial is an algebraic expression made up of variables, constants, and coefficients connected by a plus or a minus sign whose power of the variable or exponent or degree of the variable is a whole number or a non-negative integer. So I have some examples here through which we will understand like which one is a polynomial or which one is just an algebraic expression. So these are all the algebraic expressions. To verify whether it's a polynomial or not, like I said, it is made up of constants, variables like x and y, coefficients means numbers standing in front of variables connected by plus and minus signs, and the power of the variables must be whole numbers or non-negative integers. Both are same, means powers can be 0, 1, 2, 3, this type. Okay, it should not be this negative numbers, or it should not be fractions, it should not be decimal numbers. So powers must be only of this type. Now, considering this thing, let us look at the first expression. The variables are x and y. Look at their powers. If no one is there, it means 1. So power is a whole number. So therefore, this is a polynomial. But this is a polynomial in two variables, x and y, which is also denoted by f of xy or p of xy. These are just naming the polynomials. This polynomial or this entire expression is made up of x and y. That's what it's trying to say, or p of xy, or you can say t of xy. The variables inside the bracket mean that the expression is made up of these variables. So this is a polynomial. What about this? Well, here the expression is made up of only one variable, and the power, if you check the powers are whole numbers. So this is also a polynomial. And since it is made up of only one variable, so we can say it is either f of x or p of x, t of x, k of x. Okay, these are just naming the polynomial. Now what about this? Is this a polynomial? You see only one variable x. If you rewrite this polynomial, if you rewrite this expression, it can be written as 4x to the power half plus 3, right? If you remove this radical or the root symbol, then the power half will come. So I told you, in order to be a polynomial for an algebraic expression, the power has to be whole numbers. No negatives, no fractions, no decimals. So this is not a polynomial. What about this? You see here, all right, this one's power is 1. So you might say this is a polynomial, but this can be rewritten as, isn't it? If I bring it on the numerator, the power is going to be minus 1. So this is how a polynomial has to be defined. Every variable should come on the numerator, and you see that the power is a negative number, therefore this is not a polynomial. What about this? A very interesting one. Is this a polynomial? Well, this is not a polynomial. This one, it is also called a rational function sometimes, or yeah, the rational in the sense it is of p by q form, right? If you find the LCM, then x is on the denominator, so so that is why this is called a rational expression. But this is not a polynomial. What about this? Root 3. Instead of root 3, you can have any other number. You can take like, let's say 1, 2, 3, 0, any other number, let's say 5, 10. So this at once, this is a constant, this is a number, but when you look at it through the lens of a polynomial, root 3 can be written as root 3 into x to the power 0, right? Similarly, I can write a number, any number, let's say 1, because any number or any quantity whose power is 0, it is 1, right? But I can write it. So root 3 is connected with x whose power is 0. So this is also a polynomial whose power or degree is 0. Okay, so yes, this is a constant, but if it's a polynomial, then you say yes, this is a polynomial whose degree is 0, because it can be expressed in this form or in this form. So this was tricky, right? So this is something like this. What about this? Is this a polynomial? Things are getting trickier, right? So now look here. At instant, at first when you look at it, the power of y is 3 by 2. It's a fraction, and in the denominator, it's root y. So you will, you might think that this is not a polynomial. This is just an algebraic expression. But you need to sometimes, further simplify and check. Like this is y4. Right? If I remove this root, then it's going to be half. So next step, 3y, 3 by 2, this half will come up and will subtract, isn't it? So what happens? 3 by 2 means 1.5. So 1.5 minus half is 1. So this is y4 minus 3y, y to the power 1 plus 2. So you saw that this strange looking expression is also a polynomial in one variable, that is y. So we can say it is made up of y, so f of y or p of y, k of y, q of y, right? What about this? half into x square. Is this a polynomial? Yes, this is a polynomial whose degree is 2. In fact, there is a specific name for this polynomial. It is called a monomial because you see only one term. If you have two terms, we call it a binomial. Let's say if I had this x, then this polynomial would be called a binomial. There are two terms. So polynomial is a general name. Okay, this is also a polynomial where the coefficient is half. So coefficient can be a fraction, a whole number, a decimal, any number, okay, other than 0, but the power of the variable must be a whole number. So this was about polynomials. I hope it's clear. Now you can easily figure out which is a polynomial and which is not a polynomial. So let's move on to another topic. So we have a question. Suppose fx equals to x square plus 5x plus 10 and gx is x minus 2. Find the remainder when fx is divided by gx. Fx and gx are nothing but polynomials. Okay. So you just saw what a polynomial looks like. Okay. So this is called a linear polynomial, quadratic polynomial. Linear means it's the highest power is 1, highest power of the variable is 1. Quadratic, the highest power or the degree of the variable is 2. Okay. So when you divide this polynomial by this one, what is the remainder? So I guess you are familiar with this division. So how do we do it? X into how much is x square? X into x is x square. Now this will multiply the second term along with the sign. Plus into minus is minus. X into 2 is 2x. Next, we change the signs. This is positive, now it will be negative. This is negative 2x, it's going to be positive 2x. After this, we add the terms. So if you add these two, plus x square minus x square is going to get cancelled. Your answer is 0. If you add these two, you're going to get 7x. And this plus 10 will come down. Now, again come back here. X into how much is 7x? X into, along with the sign, x into plus 7 is 7x. Well, plus into minus is minus. 7 times 2 is 14. Sarah, please excuse. So after this step, again you'll have to change the sign. So this is positive, it's going to be negative. This is negative, it's going to be positive. Now add them. When you add them, plus 7x and minus 7x will get cancelled. 24. So now you cannot divide this 24 by x. Okay. So the process ends here. This is our remainder and this is our quotient. So this is how we find the remainder by division method. I hope this was a recall what you learned in your previous classes. So from here only there is we will proceed towards remainder theorem. So what happens next is let me erase the board first. All right, we come to this point. We saw that when there is a polynomial fx is divided by another polynomial gx, this was our quotient and this was our remainder. So let's say the quotient is also made up of x. I'm saying it as q of x. It's also a polynomial, and r, the remainder, which is 24. Now there is a rule in mathematics. The rule is called division algorithm. Now what does that say is that the rule tries to show the relationship between dividend, divisor, quotient and remainder. In our case, this is the dividend. So fx can be written as, when our divisor is x minus 2, it is gx into qx plus r. So if I multiply the divisor and the quotient and add with the remainder, I will get the given polynomial. That means if you simplify this, you are getting this is a very important rule. This rule is called division algorithm. It connects the divisor, dividend, quotient and the remainder. And this works in arithmetic also. For example, if you are dividing, let's say 28, a number 28 by 5. So it's going to be 5 times 5 is 25, the remainder is 3. Now with respect to the divisor, how we can express 28 is, 28 can be written as 28 is 5 into 5 plus 3, right? Next, you can think of another number. If the divisor was not 5, let's say it was 3. Then, so 3 is a 24, 3 9 is a 27. Remainder is 1. Now you can write 28 with respect to the divisor 3 as 3 into 9 plus 1. The same rule is working here. Okay, so this rule is what comes into picture while doing the remainder theorem. Now we'll move on to remainder theorem. All right, same problem. You have the same polynomials fx and gx. Now also we are dividing fx by gx and finding the remainder. Now another way of finding the remainder is that you equate gx to 0. Whoever is the divider, okay, that means x minus 2 equals to 0, so x equals to 2. So first you equate the divider to 0 and find how much is x. So x is 2. So next you have this given polynomial whom we are dividing by x minus 2. This is the one. You substitute the value of x by this one, 2. So wherever you see x, just plug in these values. Boom. So you got the remainder by just substituting the value of x. So how do we get that value? By equating the divider to 0 and finding the value of x and plugging that value here, you'll get the remainder. So this is the shortcut for finding the remainder when a polynomial is being divided by another polynomial. This is what remainder theorem talks about. Now, when is it divisible, when it is not divisible? This is divisible by gx whenever the power of gx is equal or less than the power of fx. In this case, it is less than fx, so it is divisible. If it was 2, still it was divisible, although you may find some other remainders. But if the power of gx is more than 2, then the polynomial is not divisible by gx. That is something that you need to keep in mind. Okay, so this is your remainder theorem, the application of remainder theorem. It's the shortcut for long division method. The remainder theorem states that if a polynomial fx is divided by x minus a, the remainder is simply f of a. So this is the statement you will find in your textbooks. In fact, in every textbook, whenever you read about remainder theorem, this is what it's written. But how it's verified, I hope you understood by the problem that we did. In that case, uh, this is our, let's say we had fx, which is x square plus 2x plus 10, and gx is x minus 2. Right? And we found the remainder by f of 2. So this gave us the remainder, isn't it? Which is 24. So compare this with the theorem. So in the theorem, it states that if a polynomial fx, this one, is divided by x minus a, so whoever is dividing, that is also a polynomial. Let's say that is gx. In our case, it's not x minus a, it is x minus 2. So a is a number. Then the remainder is simply f of a. Means whatever is a, it is 2. So f of 2 is the remainder, which is 24. So the focus is more on solving questions. But if you want to understand how this happened, like directly a remainder is, we are getting this value as a remainder. This comes from the division algorithm, which I discussed earlier. It states that if there is a polynomial and you have a divisor gx, the relation between dividend, divisor, quotient and remainder is what? Qx into gx, the divisor plus remainder. This is the division algorithm, isn't it? Now, in our case, you know the divisor. The divisor is x minus a, q into x, qx. Don't say q into x, this is q of x, okay? Quotient. I'm replacing the divisor by x minus a according to the theorem. Now, if you put x equals to a, then here also it will become f of a minus a, q a plus r. Now look here, a minus a is 0, 0 into this is 0. So you get f of a equals to r. So from division algorithm only, we are getting the remainder using the formula. So this is how, when we plug in the value of x, we are getting the remainder. But there are a lot of, tricky problems where instead of x minus a, you can have x plus a. So that is not mentioned in the theorem. Like how you put it here. I said that we'll have to equate gx to 0 and then solve this equation, and only we'll put the x value. So that's That's something we'll verify, we'll clarify while solving the question. But how f of a is the remainder is given by this idea. So let's move on to problems. So we have our first question. Use remainder theorem and find the remainder when the polynomial gx x cubed plus x square minus 2x plus 1 is divided by x minus 3. So here the divisor is x minus 3 and the dividend is this. So by using remainder theorem, how do you do it? Whoever is dividing, we equate that to 0. This one is dividing, so you'll write let x minus 3 equals to 0 and x equals to 3. Now you'll plug in this value in this polynomial. So g of 3 is wherever you see x, put 3. So 3 cube is 27, 3 square is 9, 6 plus 1. Add all the positives. So 9 plus 1 is 10, 27, 37. 37 minus 6 is 31. So g of 3 is 31. This means what? This means that when gx, this polynomial, is divided by x minus 3, the remainder is 31. So I hope you understood. Let's move on to another one. So we have another interesting question. Find the remainder when px, the polynomial, 4x cubed minus 3x square plus 2x minus 4 is divided by this, which is also a polynomial, 2x minus 2x plus 1. So what will be the remainder? Obviously you can find the remainder by long division method, that's no problem. But since we know the remainder theorem, so we'll go for the shortcut. What do we need to do? First, we'll have to equate the divisor to 0. You can name the divisor by some function, like let's say this is already named as px, so you'll have to give this something else. You can say let fx equals to 2x plus 1, no problem. Okay, then say fx equals to 0. That is what? Which means 2x plus 1 equals to 0, and solving this one I'll get x is minus half. So you need not name the divisor by any, name the polynomial by any term, like let's say fx, gx, qx, or even if you do so, it's not a problem. Okay, ultimately you'll end up here only. If you directly equate this to 0 and solve and find x, it's okay. Now what do? You substitute the value of x in this polynomial. So p of minus half, we'll see how much is it. Well, you can also try in your notebook and try to get your answer faster than me. So minus half to the power 3 is, we're going to get a negative number, 1 by 8. This, square of a negative number is a positive number, 3 to 1 by 4. This minus 2 gets cancelled, 1 minus 4. So I'm erasing the question. So we have p of minus 1 by 2 is 2. It's minus 2 upon, sorry, minus 1 upon 2 minus 3 by 4 minus 5. Take the LCM, it is 4. So 2 times 2 is 4. So 1 will also multiply 2. It's going to be minus 2. 4 times 1. So 3 will multiply 1. So 1 will multiply 4. So 5 will also multiply 4. It's 20. So the answer is minus 25 upon 4. So this means when the polynomial is, when the given polynomial is divided by 2x plus 1, then the remainder is minus 25 by 4. Alright, we'll move on to another type of question. So question number 3 is like this. When x cube plus 3x square minus kx plus 4 is divided by x minus 2, the remainder is k. Find the value of k. Here we know the remainder. So we just have to find the unknown k. So the process is the same. Whoever is dividing will equate it to 0 and find x. Obviously x is going to be 2. Okay. So you'll write let x minus 2 equals to 0. When you solve this, you'll get x equals to 2. Now plug in the value here. You'll have to name the polynomial first. Okay. So let this be, since it's made up of x, you can write let p of x is this is just naming the polynomial. Now, how do you find the remainder? You will, whoever is dividing, we equated it to 0, found the value of x, will substitute the value of x here and will find the remainder, isn't it? So remainder is given by p of 2. So this is 2 cube plus 3 2 square minus k into 2 plus 4. You know what? We know the remainder. P of 2 means find the remainder when this polynomial is divided by x minus 2. What is the remainder? The remainder is k. So this is equal to k. Now solve this. 2 cube means 8 plus 4, 3 4s are 12 minus 2k plus 4. Sorry. It's not 14, it's 12. Now let's add. So this is going to be 12 plus 8 is 20, 20 plus 4 is 24. You bring this to here. So it's going to be 3k equals to 24, 4k equals to 8. So when you see this kind of question, this is how it's solved. I guess you like this one. Let's move to another question. Alright, let us solve this question. It says if the polynomials ax cube plus 4x square plus 3x minus 4 and x cube minus 4x plus a leave the same remainder when divided by x minus 3, find the value of a, this unknown a. So when you divide these two polynomials by another linear polynomial x minus 3, you get the same remainder. So from that you'll have to find a. So let us solve this question. First we'll name the polynomials. So let us say this is fx. Since it is made up of x, a is a constant, it's a number. Okay. You may say let this be, okay, let fx be this, and another one is x cube minus 4x plus a. So when fx is divided by x minus 3, when fx is divided by x minus 3, what is the remainder? The remainder is given by f of 3, right? How do we get it? When we divide a polynomial by another polynomial, whoever is dividing will have to equate it to 0. Right? X minus 3 equals to 0 and x equals to 3. And we'll substitute that x equals to 3 here, means fx. So this will give us the remainder. So when fx is divided by x minus 3, the remainder is f of 3 or f3. Similarly, when gx is divided by x minus 3, the remainder is g3. g3 is the remainder when gx is divided by x minus 3. So what's next? Next we have fx. They say that the two remainders are equal. That means f of 3 is equal to g of 3. This is kind of given. So your f of 3 is, I erased the polynomial, it is a 3 cube plus 4 3 square plus x minus 4 equals to g3. G3 is here only, is 3 cube minus 4 into 3 plus a. So can you solve this? Now this becomes an equation where a is the only unknown. So we'll have to solve and find a. So this is 3 cube is 27. 27a plus 3 square is 9, 4 9s are 36 plus 9 minus 4 equals to 27 minus 12 plus a. So if you bring this a on your left hand side, it is 26a equals to 27 minus 12 is 15, and out here it is 9 minus 4 is 5. 5 plus 36 is 41. You send that 41 to the other side. It's 41. So it is your a is minus 26. 40 minus 15 is 35. Sorry, 25 plus 1, 26 out of 26. So your a is minus 1. This is your answer. So I hope you understood. Okay, let us look at this problem. It says px is 2x cubed plus 4x plus 6 and gx is x plus 1. Calculate the remainder when px is divided by gx. So this is a very simple one. Let's see what happens. Okay. So if this is dividing, the one which is dividing will equate to 0. That is x plus 1 equals to 0, means x is minus 1. So in order to find the remainder, we substitute the value here by this minus 1. So this is here it is minus 1, 2 times minus 1 is minus 2, so minus 4 plus 6, so this is 0. So what do you see here? That the remainder is 0. Remainder is 0 means the one which is dividing, the divider is a factor of the given polynomial. Means it's exactly dividing. For example, if you were dividing 10 by 2, so 2 times 5 is 10, so remainder is 0. So in this case, what do we say? That 2 is a factor of 10 because 2 exactly divides 10. Similarly, 8 is a factor of 24 because 8 divides 24 exactly, leaving no remainder. So this problem, the remainder theorem only. Okay, so this leads us to another theorem, that is factor theorem. It says that if the remainder is 0, if the remainder comes 0, then the given polynomial is the divider is a factor of the given polynomial. All right, let us write the theorem. So here we have our factor theorem. It states that x minus a is a factor of fx if and only if the remainder is 0. That is f of a equals to 0. In short, what it is trying to say is that you have a polynomial fx, it is being divided by x minus a, and if when it is divided by x minus a, what is the remainder? Remainder is f of a, isn't it? So if f of a becomes 0, then fx, then x minus a is a factor. Simple as that. So you may think about, what about this if and only if? Well, this is not explicitly explained in school, but in short, you may understand it in this way. If f of a equals to 0, a real number a, right? A real number means a number that can be placed on a number line. You know, a number line, 0 is, you have a negative side and you have positive sides till infinity on both the sides, negative infinity and positive infinity. Any number that can be placed on this number line is a real number. So f of any real number becomes 0 for a given polynomial fx. Then x minus that real number is a factor, or if this is a factor, then f of a must be 0. That's what it means by if and only if. It talks about both the ways. So with respect to this theorem, we have some problems. So let's do it. So here we have a question that says, show that x minus 1 is a factor of x cubed minus 7x squared plus 14x minus 8. Hence, completely factorize the above expression. First, you'll have to prove that this exactly divides the given polynomial, means there is no remainder, the remainder is 0, and you'll have to further factorize this expression. So how do you prove that this is a factor? We'll have to show that the remainder is 0. So when this divides the expression, let's say this expression is it's give a name, that px equals to x cubed minus 7x squared plus 14x minus 8. So if this is divided by this, x minus 1 equals to 0, x equals to 1. By now you can, you must have understood that, when the divider is given as x minus 1, the remainder is directly p of 1, because this will equate to 0 and 1 will go that side. So this thing is, this thing becomes automatic. So here replace the values of x by 1. So 1 cube is 1 minus 7 plus 14 minus 8. So this is 7 and 8 is 15. So 14 plus 1 is 15. So this is 15 minus 15. It is 0. So remainder is 0, means that x minus 1 is a factor. Hence x minus 1 is a factor. This comes from factor theorem. So next, we'll have to factorize the expression this completely. So what does that mean? What does factorization of an expression mean? It means to show that the expression is a product of factors. For example, if you have a number, let's say 16, someone says factorize this 16. It means to show that this is a product of factors. For example, you can factorize this 16 in this manner. Let's say 2 into 8, or 4 times 4. Well, 16 into 1, this is also the factorization of 16, but this is called a trivial factorization. This is always true. So we are bothered with these two. So other ways of showing 16 is 2 times 8 or 4 times 4, or prime factorization of 16 is means showing 16 as a product of only prime number or prime numbers. So these are the possible 3 factorizations of 16, excluding the trivial one. So likewise, instead of 16 we have an expression. You'll have to show that this expression is also a product of something into something into something. Like it can be product of 3 factors, product of 2 factors. So we found one, so that is x minus 1. So if this divides, x minus 1 divides the given expression, the remainder must come 0, because we have verified that this is a factor. So let us divide. So how do we do it? First, x into x square is minus 8. We change the sign and we add them. It cancels out and the remainder is 0. Well, remainder has to come 0 because we know that this is a factor. So what did we show? All right, I hope you understood the division. Now what can I write is that x cube minus 7x square plus 14x minus 8 is equal to x minus 1 x square minus 6x plus 8. You all agree? If I multiply these two, then this is going to be the product. So is it completely factorized? Means you showed the expression is something into something, but is it completely factorized? It may be, but you'll have to check whether it can further be broken down or further be factorized. So this, you can't do anything with this, but this one is a quadratic polynomial, means the degree is 2. See, check whether if this can be factorized. So we factorize a quadratic polynomial by middle term breaking method. So how do we do it? What is the coefficient of x square? It is 1. So multiply the coefficient of x square with 8. So 1 times 8 is 8. Now write the possible factorizations of 8. So 8 can be written as 2 times 4 or 8 times 1. So these are only 2 possible factorizations of 8. We are not concerned with the prime factorization. So other than prime, these 2 are the only possible. Now choose the one such that out of these 2, choose one such that the product of the digits is 8. The sum or difference of the digits is the middle term. Means if you add or subtract them, it should come 6. So this is the answer. Means 2 times 4 is 8. 4 plus 2 is 6. So this can be written as x square. You'll have to take care of this negative sign also. So choose the bigger number, give the bigger number this symbol, 4x. Now this smaller number, you'll have to adjust by yourself. So you'll have to write minus 2x. You cannot write plus 2x. If you write plus 2x, it's going to be 4x minus 4x plus 2x, that is minus 2x. So keeping that in mind, first you bring this, bigger number will take the sign always, even if it's a positive number, it's a plus sign. So 4x. Now this 2 you'll have to adjust, which is going to be a negative 2x plus 8. Now, if you add them, the answer is minus 6. This has to be consistent. Next. So here I'm going to give a curly bracket and take common from the first two terms. So it is x minus 4. From here the sign is going to come down. 2 is common. X minus 2 into how much is plus 8? Minus 2 into minus 4 is plus 8. In fact, these two entities or quantities inside the bracket must be same and consistent. So here the common between the first two terms, this term and this term is x plus 4. So from here also you take common. So now you may leave the curly bracket, or I'll show it. X minus 4 and x minus 2. So from this point, the next line you may remove the curly bracket because it's just multiplication between the three factors. So this is a complete factorization of the given polynomial. This is what the question demands. So this is how it's done. I hope you understood. So we have one more method to get this answer. So how do we came to this point? Obviously, first the verification was there that you can escape. That is done by finding the remainder and checking whether it's equal to 0 or not. Next, we did the long division method and found one of the factors which turned out to be a quadratic polynomial. And further, we factorized the quadratic polynomial into linear factors by middle term breaking method. So what we'll be doing next is that we won't do this long division method to find the quadratic polynomial. We have another method which is more time saving. So how do we do it? I'll show you how. The polynomial is x cube right. So this is the given polynomial which we'll have to factorize. So we know one of the factors, x minus 1. So you write this thrice. And give a space between them. Now what we'll do is, you find a number which when you multiply x, it should come this term, the first term. So it is x square. So x square into x is x cube. But you'll have to multiply the next term also. So x square into minus 1 is minus x square. You write this somewhere. Okay. Minus x square. So now what you should multiply to this x so that the answer is minus 7x square. You already have 1 minus x square. So it is, if you multiply minus 6x. If you put here minus 6x, then it's going to be minus 6x into x is minus 6x square. So the two of them will add and the sum is minus 7x square. Right? Next, Minus 6x will also multiply 1, minus 1. So minus into minus is plus, 6x into 1 is 6x. So this is extra. Now what you should put here and multiply x such that the answer is 14x. You already have 6x. So 6 plus how much is 14? 8. And it's also positive 8. So 8 into x is 8x. So 6x plus 8x is 14x. And 8 plus into minus is minus, 8 into 1 is 8. So this is how things will be automatically balanced. So keep these things in mind. Next, it's like you have 3 terms: first term, second term, and the third term. So out of these 3 terms, the common is x minus 1. The rest is x square minus 6x plus 8. So you directly arrive to this point. Now the similar method follows. This is a quadratic polynomial. You break down by middle term break. So I hope you understood. So from our upcoming questions, what we'll do is we'll apply this method and find the other factor, whether it's most of the time it's going to be a quadratic polynomial, which we will further factorize. We won't do the long division method. So let's move on to another question. Alright, we have this question. Factorize the expression x cube minus 7x square plus 15x minus 9. So you'll have to show that this expression, this algebraic expression or a polynomial, is a product of factors. Like this has to be equal to something into something into something. So from where will you start? You don't know even one factor. So what we'll do here is first name this expression. Since it is made up of x, let's say it's px. Now we'll check those values of, values of x for which the expression will become 0. I mean, if x equals to, let's say, 1, minus 1, 2, minus 2, 3. Let's say if x equals to minus 1 and this becomes 0. That means the remainder is coming 0, isn't it? So if you put x equals to minus 1, for example, what happens? Let's see. It's going to be, this is minus 1 cube this is minus 1. Minus 1 square is 1, so it's going to be minus 7, minus 15, minus 9. So therefore, this is going to be a non-zero number. It's not going to be 0, isn't it? Hence, we cannot do anything with this. We are trying to make this expression 0. Let's try with 1. So this is going to be 1 cube minus 7 plus 15 minus 9. So this is 7, 16. This is 16 minus 16. Oh. So from remainder factor theorem, especially from the factor theorem, if f of a equals to 0, then what? Then x minus a is a factor of fx. The same thing. So p of 1 equals to 0 means x minus 1 is a factor of this polynomial. So remember this. This is a factor theorem. P of 1 equals to 0 means x equals to 1. Then what do you say? X minus 1 equals to 0. So x minus 1 is a factor. Whatever value you give for x, you write like this, isn't it? Let x equals to 1, and then this happens. So the divisor is x minus 1 is a factor of px. So you found one factor by trial and error method. This is called trial and error method. You'll have to find by yourself. So usually one of the factors lie in a close range around 1 to 3, but you need to try with different signs as well. For example, my first one minus 1, it did not work, but 1 it worked. You can try with 2, minus 2, 3. Sometimes you like half is also there, plus minus half. Usually go for 1, 2 and 3, plus minus. And I hope you you get your answers in your first trial. So next, what we'll do? So now we'll break down this. So we have found x minus 1 as one of the factors. We'll write this. We'll write in this manner. Now what needs to be multiplied to x here so that the product is x cubed, that is x square. X square into x is x cubed. X square into minus 1 is minus x square. This has to be written somewhere in the rough. The minus x square is there. I'll have to multiply something with this x, and the answer with this in addition or subtraction with this x square minus x square, it should be minus 7 x square. So it is minus 6x. So minus 6x into x is minus 6x square. So if you add these two, you will get minus 7x square. But this will also multiply minus 1, minus minus plus. So this is your going to be 6x. We have 15. So so 6x plus how much is 15? Plus 9. So plus 9x, 9 into x is, if you add these two, you get 15x, and plus into minus is minus, 9 into 1 is minus 9. So it's completely balanced. Hence, from these three terms, x minus 1 is common, and the rest is x square minus 6x plus 9. So we further factorize this quadratic polynomial by Miller-Tombreck method. So this can be written as 9. 9 is 3 times 3 is 9, and if you add these two, the answer is 6. So it's going to be x square minus 3x minus 3x. If you add these two, you are getting minus 6 plus 9. So let's find common from first two terms. And this sign will come here, and the common from these two terms is 3, x minus 3. When you multiply, you should get this, and also these two are always equal. With that, so common from these two terms is x minus 3. So x minus 3 into x is this term, x minus 3 into minus 3 is this term. So altogether, if you multiply these three terms or these three factors, you'll get the expression. Since here x minus 3 is being multiplied twice, so you can write this as x minus 1, x minus 3 whole square. So this can be written as this. So this is now this polynomial or this expression is completely factorized. So this was an interesting question. Let's move on to another one. Okay, let us solve this question. It's a really valuable question. It says if x minus 2 is a factor of the expression 2x cubed plus ax squared plus bx minus 14. If this is a factor of this, and when the expression, means this one, is divided by x minus 3, it leaves a remainder 52. So when you divide this expression by x minus 3, you have a remainder 52. Find the values of a and b. This a and b. So let us solve this question. First, we'll name this polynomial. Let's say let's give the name fx. Now, x minus 2 is a factor of this, factor of fx, means this divides fx. So if this divides fx, then the remainder is given by f of 2, isn't it? You equate x minus 2 equals to 0, equate this to 0, x is going to be equal to 2, and you put the value 2. So put 2 wherever you see x. F of 2 means the remainder when this divides the polynomial, and you know the remainder is 0 because x minus 2 is a factor. So now 2 cube is 8, 2 plus 2 into 8 is 16, and 16 minus 14 is 2. So this is 4 minus 4a plus 2b. So if you divide the entire equation by 2, so you'll get 0 equals to 1 minus 2a plus b, right? So it's going to be, I'm erasing the question. So this is going to be minus 2a plus b equals to minus 1. Let's keep it like this only. Let's say this is equation 1. Okay. Next, if you divide the polynomial by x minus 3, the remainder is 52. Remember that. So that means if you divide the polynomial by x minus 3, the remainder is f of 3, and the remainder is f of 3, you know the remainder is 52. Now let's substitute f of 3. So f of 3 is this 3 cube is 27, 2 into 27 is 54, plus 9, 9a plus 3b minus 14 equals to 52. So this is 9a plus 3b. So 54 minus 14 is 30. Sorry, 40. 40. If you send to the other side, it's going to be 52 minus 40. So it is 12. So 9a plus 3b equals to 12. You divide the entire equation by 3. So it is going to be 3a plus b equals to 4. Let's say this equation 2. Now let's solve equation 1 and 2. So solving equation 1 and 2, we'll get the values of a and b. So 3a plus b equals to 4. So when we solve simultaneous equation in two variables by elimination method, so the things that need to be kept in mind is that one of the variables must be equal. So we have b equal. If they are not equal, we'll have to multiply. Okay, we'll have to multiply by the LCM of the coefficients of that variable. For example, if you want to make a equal, means here it is 2a, it is 3a, forget about the sign. If you want to make them equal, you'll have to multiply these two equations by the LCM of coefficient of a, 2 and 3. So LCM of 2 and 3 is 6. If you multiply this by 6 and this by 6, no, 3, 6, 3 into 2. Oh, LCM of 2 and 3 is 6. So you'll have to multiply this equation by 3. So 2 times 3 is 6, and this by this entire equation by 2, so that 3 times 2 is 6. Obviously there will be changes in other variables and the constants here, but we are making a equal. But in this case, one of the variables is already equal, so we don't have to do anything. Next, once they are equal, we need to have opposite signs. So in this case, both of them are the same sign. So we can change the sign of this b by multiplying the entire equation, this second equation, by -1. So if you multiply this by -1, it's going to be minus 3a minus b minus 4. Now add them. So if you add them, so it's going to be minus 5a. If you add them, it's going to get cancelled. This is minus 5. So hence, how much is a? A is 1. So we found a. What about b? You can substitute the value of a in any one of the equations and find b. Let's do it here. So minus 2, a is 1 plus b equals to minus 1. So this is minus 2 plus b equals to minus 1. So b is 1. So a is 1, b is also 1. You may verify the values by substituting it in one of the equations. Let's say a is 1 and b is 1. Put it here. So this is going to be minus 2 into 1 plus 1. So this minus 2 plus 1, it is minus 1. Put it here, minus 1 is 3 plus 1 is 4. So our answer is correct. So this is how it's done. Let's move on to another question. All right, this is our last question of a different kind from this topic, remainder and factor theorem. It says, what number should be subtracted from the polynomial 2x cubed plus 5x squared minus 14x plus 10 so that the resulting polynomial is exactly divisible by gx, which is 2x minus 3. So how much or what quantity must be subtracted from this so that the resulting means after subtraction the 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 difference that you get is exactly divisible by this one. So here what you need to understand is, for example, let's say you were dividing 17 by a number 3. So 17 is not exactly divisible. So how much should you subtract from 17 so that it is exactly divisible by 3? Something like that, similar to that question, this one. So 3 times 5 is 15. So remainder is 2, means if you subtract 2 from 17, then it is exactly divisible. And that's true also. If you subtract 2 from 17, it is 15. So 15 is exactly divisible by 3. So the remainder determines how much you must subtract. So here also what we'll do is we'll find the remainder when we divide px, the polynomial px, by gx, and find and see how much it comes. So let gx equals to 0. So if you solve this, you'll get x equals to 3 by 2. So when we divide px by gx, the remainder is given by p of 3 by 2. 𝐴84 by 4. So this is 28 by 4, and it is 7. This is your remainder. So what must be subtracted? 7 must be subtracted from the polynomial px. 7 So if you subtract 7 from px, the result, that is if you this is px, isn't it? In place of 3 by 2 you have x. If you subtract 7, it is going to be the same. This is 2x cubed plus 5x squared minus 14x plus 3 will be there because you subtract 7. So that polynomial is exactly divisible by this 2x minus 3. That's what it means. So here we end our class. Well, this brings us to the end of this video, and I hope you learned and you understood what we did in today's class. Well, I tried to solve every type of problem that you may encounter in this chapter or in this topic at high school level. And now you can practice from the questions that you have in your textbooks or from practice papers. And for more videos like this, do subscribe the channel and do not forget to press that like button. Thank you. See you in the next class.